Hi guys! So it is now day 2 of our online class, and so we're going to be talking about multiplying polynomials by a monomial. So we did a lot of adding and subtracting polynomials yesterday and working through all of those homework problems. If you have questions about homework sets, please shoot me an email. We can set up a time to do a FaceTime call if that makes it easier. I'm here to help y'all, so you're not in this alone. So getting started today, we're still going to be dealing with polynomials and using monomials. So as a reminder, polynomials, poly meaning many, so this is our many terms. A monomial, mon being a prefix for one, this is a one term, okay? Later on this year, it will be a big deal for us to use more than just monomials, but we're going to start with multiplying a monomial by just one term by polynomials today. So our goal is we will learn to multiply a polynomial by a monomial. So right now, just so you can see it easily, I have a monomial here on the outside in blue, and then I have my polynomial in red. I'm using colors right now because I think it helps to see where things are coming from. So when we learned about distributing, when we had a number on the outside, I take it and I multiply it by the first term and the second term. We're going to do the same thing now, except now we have to remember our exponent rules that we learned back in chapter 7. So I'm going to use colors because I think it helps to see what's going on. So I'll have, I like writing the polynomial term first. So I'm going to write, I have 3x, and I'm going to multiply it by 2x. The reason I like using the polynomial term first is because then I can just use the sign in the problem for the beginning of each term. And so notice now I ended up going through and I multiplied each number by 2, or each term by 2x. So now, as a reminder, here's the important part with our exponent rules. Those x's have 1s on them. So when I multiply the coefficients, so 3 and 2, I'm going to have 3 times 2, which is 6. But then I have x to the first times x to the first. So remember, that's when I take my exponents and I add them. So when I add those exponents, that's going to give me 6x, 1 plus 1 is 2. So 1 times anything is itself, so this last term is a little bit easier because it's just going to be 2x. So my final answer is 6x squared plus 2x. So we're just going to be distributing. We just have to remember all of our exponent rules we've used before. So the degree on both terms became larger because I multiplied it by another variable. So let's go and do another one. Before we do another one, let's get our steps. So first, we want to eliminate grouping symbols by using that distributive property. That's when I wrote out who was getting multiplied by who. Then we'll want to go through and multiply our coefficients together. After we multiply coefficients, then we can go in and add the exponents of our powers and our variables with the same base. It is okay to do those in the same step, which is why I grouped them together in this stage. Okay. So lastly, you do want to simplify and double check that it's in standard form. I've gotten really good at trying to make things in standard form. It might take you some practice, but remember, standard form means the highest degree first. So at the end of every problem, just ask yourself, hey, is this in standard form? If it's not, rearrange the terms. If it is, you're good to go already. So let's go do some examples. So I'm going to get us started off using colors. I will move to just one color later on so that you can see what it'll look like normally. So right now, I'm going to take my 4x squared and I'm going to distribute it to every term on the inside. And so this is why I like going in and writing my first term, and then I go in and multiply it by whatever my other term is, by my monomial. So the reason why I do that is because I have a lot of different sign changes in here in the middle. So like that 3y squared is negative, and I might have lost that negative if I wrote my monomial first. And so right now, I'm just writing out who's getting multiplied. Okay, so this is the stage in which I think it's easier to help you see who's getting multiplied. I like underlining my separate terms. So when I'm done with this problem, I should have 3 terms only. So first I'm going to multiply my coefficients in my first one. So 5 times negative 4, that's negative 20. Then I will have y raised to the 4 plus 2. So my final answer for that term is negative 20 y to the 6th. So in this next one, I have negative 3 times negative 4, which will be positive 12 y to the 2 plus 2. So that'll be plus 12 y to the 4th. And last but not least, my last term, 2 times negative 4 is negative 8. And I only have the y squared. I didn't have another y to combine it with. So that'll be minus 8y squared. When you're done, double check your powers and your degrees. So I have 6, 4, 2. Is that going down from left to right? In this case it is. Because of that, this is my final answer. If they're not going down in descending order, then you are not done yet. So let's go do another example. Go and try this one on your own right quick. I'm going to go ahead and pause the video. I'm going to work it out and show the answer in a moment, okay? So go work it out on your own right quick. Okay, so if you finish now, double check and see what happened. So notice that I did put a lot of 1s on the w's that all had exponents of 1. That was so I would remember, hey, don't forget to add this exponent when I'm multiplying w times another w. So with that, in my final answer though, that regular w at the end doesn't have the exponent of 1, and that's because in simplest form, we don't write it. And so it's okay if you write it in the step above, but in your final answer, go ahead and don't write it out. How did that one go? If you have questions, let me know. We're going to keep going. So let's do one last one on our own, and then we will do our next process. Okay, so if you have finished that problem, here is the answer. So parentheses are a pretty big deal when you're distributing a monomial, because if not, it's going to look like I have a ton of subtraction in like terms that I did not have. So please be very, very careful and use parentheses. It doesn't take long to add them in, but it is important that we use them, especially with one that has so many negatives like this one does. So now we need to talk about some that might have a lot more steps. So what about with this one when I have multiple? We're going to start with this one just like we did the other ones, okay? So I'm going to write my 5c to the 1st, d to the 7th, times c squared, d cubed. Just because there's more variables, don't let it be more intimidating. So then I'll have my minus 3c cubed, d squared, times c squared, d, that square didn't look good, c squared, d cubed, minus 4d cubed times c squared d cubed. So I'm going to underline these to help you see the different terms a little bit better, because they do start to blend in together when you have this many letters floating around. So this would give me 5, because it's my only coefficient this time. So I'd have c to the 1 plus 2, and I have d to the 7 plus 3. Just like we learned with our exponent rules. And then, so that's one term. So that would give me 5c cubed d to the 10th. So then in my next term, I would have negative 3c cubed plus 2 raised to the d, 2 plus 3. That'll be minus 3c to the 5th, d to the 5th. And then last but not least, I would have minus 4. I don't have anyone to combine with c, so it'll just hang around. So my c squared will stay c squared, and then I'll have d to the 3 plus 3. That's minus 4c squared d to the 6th. And that's going to be it for that problem. So when you have multiple variables, just combine the ones that are the exact same base and add your exponents. Okay. Now, yes, each of these terms has C's and D's, but this first one here has a C cubed, and a D to the 10th. No other term has those two combinations together. Because of that, I cannot combine them anymore. They are stuck as they are. Okay. Let me know if you have any questions through an email, through a message. I am here to assist. So let's go ahead, and we've already done that. When we have multiple, we'll still go in the same order that we talked about before, okay? But we might have to do that whole distributing process twice. For example, like this problem. So we're going to have, wrong example. So I'm going to have to distribute, I don't know what keeps happening, guys. I'm sorry. We're just going to do this one. I will first have to deal with distributing here, and then I will have to deal with distributing at the back. Okay, so for this first one, I would have 4t squared times t to the first plus 15t to the first times t to the first plus 4t to the first. So that's 4t cubed plus 15t squared plus 4t to the first. Now over here on this other portion, since I have a second step I have to distribute, that would be -4 times 3t and a -4 times -1. So it's going to be -12t plus 4 when I multiply that 4 by -1. So now I do have to combine like terms when I had multiple stages. So when I go to combine them, okay, so I'm going to look across the whole entire thing. I'm going to start off with the highest degree I see, and that's 4t cubed. I don't see any other cubes, so I'm good to go ahead and write it down. That part is already done. So next is going to be my squared term. I only have one of them, so I'm good to go ahead and add it in. Now I have two of them to the first degree. Okay, so what is 4 minus 12? It is -8, so I have -8t. 4 doesn't have any like terms, and it is my last one, so it just gets to be added to my problem. So now if I check out my exponents, they do descend. I go 3, 2, 1, 0 because 4 is a constant, and we are done. Okay, so we do the same thing. We're going to skip that example. We're going to go ahead and start talking about some polynomial equations. Okay, so with polynomial equations, first we're going to remove grouping symbols. As a reminder, grouping symbols mean parentheses. Okay, so combining like terms, that means variables of the same degree on the same side. So if they have a degree on the opposite sides, that's what we'll do in the next couple steps. Okay, so our next step is to move all the variables to one side. That's going to allow me to combine the things that are on the opposite sides together. And then we'll undo addition and subtraction, and then multiplication and division in order to solve for the remaining variable that is there. Okay, so if you need some more time with these steps, press pause. I'm going to go ahead and start some examples. So first things first, it said get rid of my grouping symbols. So to start with, I need to distribute this negative 6. So I have negative 6 times 11, which is negative 66. But I also need to multiply it by my next term, which is negative 2c, which would give me positive 12c. And on the other side, we have to distribute that 7. So this is going to be 7 times negative 2, which is negative 14. The 7 also has to get multiplied by that other negative 2, so that's negative 14c. In this particular problem, I don't have any like terms on the same side. So because of that, we're going to go ahead and move my variables to the same side. So first of all, I'm going to go in and identify my variables. So in both, I only have 1 degree this time, which is nice. We will have some with some higher degrees. And so with that, when I go to move them onto the same side, I've noticed that we end up with one's positive and one's negative. So remember, we want to move the negative one first because that'll prevent me having to deal with extra negative signs that I don't want. So to move a negative, we add. So I'll add 14c to both sides. And so when I do that, on my right side, I'm left with negative 14. And over here, I have negative 66 plus, well, what's 12 plus 14? So that's going to be a 26, and I will keep my c. So next step, I need to undo addition on the side with the variable because I want to solve for c. So I'm going to add 66 to both sides. And so with that, I will have 26c. So remember, when they're different, I need to subtract. So I'm going to set it up on the other side separately. So that would be a 2, and this would be a 5. And so with that, I have 52 left over here, and it should be positive because 66 was positive. My next step is going to be to divide. And so c should equal, well, what's 52 divided by 26? In this case, it is 2. So c equals 2, and that is my final answer. So let's go do another one. Okay, so this is the last one we're going to do today, and then I'm going to let you go and get started on your homework. So this one has a lot of steps, and that's on purpose because you might have some with a couple of steps in your homework, okay? So I'd rather you see a challenging one with me before you see one for the first time in your homework. So most of the ones you have in your homework are more similar to the one before this one, okay? So I'm going to go ahead and identify, hey, where's my equal sign? Because that's going to help me not lose it. So first of all, I need to distribute this n to the first 2. Well, n times n, that's going to be n to the 1 plus 1, which is 2. And then when I multiply n times negative 4, it's just going to be negative 4. Okay. Then I would have plus positive n times n, which is n squared, and then positive n times 8, which is plus 8n. Moving on to our other side, I have n times n, which is n squared, and n times negative 13, which is negative 13n. And then I have this positive n times n, which is plus n squared, and n times positive 1, which will be just plus n. And then last but not least, we have 16, which is just hanging out. So this is so many terms and so much stuff going on. What will help is if you do follow the steps in order. So have those steps out when you're working on your homework assignment, when you're working on the part in which you're combining things. So with that, I'm going to go in to both sides and get like terms on each side of the equation. So to get started, I'm going to start over here on the left-hand side. So I have 2n squares, so I'm going to have 2n squared because they were both positive. Now I have a positive 8n and a negative 4n. So 8 minus 4 is positive 4, so I have plus 4n. And then that side is now done. So over here on my right side, I have 2n squares, so I'll have 2n squared. I have a negative 13n and a positive n. Remember, that's a 1n, and so that would be minus 12n. I don't have anyone to combine with 16, so I'll have plus 16. By combining on each side first before you move forward, it's going to give you less terms to deal with and make this a little bit easier to work through pieces. So now let's get the variables to one side. Because I have 16 over here all on its own, I want it to stay on that right side by itself. So what I'm going to do instead is I want to subtract 2n squared, and when I subtract it, I want to write it underneath the other one. You're allowed to move all the variable terms at the same time. So I'm going to go ahead and add this 12n, and I'm going to write it right underneath that 4n at the same time. What that's going to do is it's going to allow me, A, to save a step, but I'm done moving my variables all in one step. So on my left-hand side, I'm left with just plain old 16. On the right-hand side, what is 2n squared minus 2n squared? Well, 2 minus 2 is 0, so that gives me a 0 plus 4 plus 12 is 16n. So I actually have 16n equals 16. How do we undo multiplication? Well, we divide, so I'll divide both sides by 16. When I do that, I am left with, I'm left with n equals 16 divided by 16 is just 1, so that's all it equals. So when you have lots of steps, it's okay to do it in pieces. Don't try and do everything at the same time. If you need to use colors, use colors. It helps me see where things go and where they went. It helps me make a few less mistakes. So if you need to pull out some pens to work them out, do it. That helps you find out what's going on. So today, your homework is going to be, I need to add a new page. Hold on, guys. So we're going to be on page 500, and we're going to do problems 1 through 17. Okay, so this one will be due tomorrow on 3/27 at 3 p.m. So you'll do your work on paper, take pictures of it, and then upload it onto Moodle, or you can use your iPhone if you have one to scan it using the directions I sent in order to still submit it on Moodle. This will allow me to get you feedback a little bit more directly, and I can give you feedback on your homework on Moodle. After 3 p.m., I will be uploading answers, so no late assignments will be accepted. Okay? Let me know if you have any questions. I am here to help you. I hope you'll have a great day.